WebGPU is available in Chrome 1.13. I remember when WebGPU was introduced, it was found that it became very popular and was used by almost every page. But closer inspection showed that its use was to get users' IP address for better fingerprinting. I predict that WebGPU will be mainly used for the same purposes. Nobody needs new fancy features. What people really need is more reliable fingerprinting. This is proven by number of uses of WebGPU for fingerprinting versus number of uses for communication.
But closer inspection showed that its use was to get users' IP address for better fingerprinting. Maybe that's why it fell to the wayside. Scripts are no longer allowed to get the local IP address, taking with it the most useful aspect of WebRig, true serverless P2P without Internet 1. I'm not saying that I disagree with the decision, but still sad that we can't have nice things.
In case you confused this with WebGPU as I did. WebGPU is a new API for the web, which exposes modern hardware capabilities and allows rendering and computation operations on a GPU, similar to Direct3D 12, Metal, and Vulkan. Unlike the WebGPU family of APIs, WebGPU offers access to more advanced GPU features and provides first-class support for general computations on the GPU.
And to prevent device fingerprinting, all the operations are specified to deterministically produce the same bit-exact results on all hardware, and the feature set is fixed without any support for extensions, right? Or is this yet another information leak anti-feature that we need to disable?
There is no way to escape fingerprinting. Just one example, a script which runs many different types of computations. Each computation will take a certain amount of time depending on your hardware and software. So you will get a fingerprint like this. Computation 1 ***. Computation 2 ***. Computation 3 ***. Computation 4 ***. Computation 5 ***. Computation 6 ***. Computation 7 ***. Etc. There is no way to avoid this. You can make the fingerprint more noisy by doing random weights. But that's all. Just put WebGPU behind permission, and the problem is solved. I don't understand why highly paid Google and Firefox developers cannot understand such a simple idea.
For a user to correctly answer a permissions dialog, they need to learn programming and read all the source code of the application. To say nothing of the negative effects of permission dialog fatigue. In practice, no one who answers a web permissions dialog truly knows if they have made the correct answer. Asking the user a question they realistically can't answer correctly is not a solution. It's giving up on the problem.
It's possible to have the runtime execute the computations in fixed time across platforms.
This would essentially mean that every computation would have to run as slow as the slowest supported hardware. It would completely undermine the entire point of supporting hardware acceleration. I'm sympathetic to the privacy concerns, but this isn't a solution worth considering.
Could you explain what techniques would make this possible? I can see how it's possible in principle, if you say, compile JS down to bytecode, and then have the interpreter time the execution of every instruction. I don't immediately see a way to do it that's compatible with any kind of efficient execution model.
The rest would be optimization, while keeping the timing side-channel constraint in mind. Hard to say what the performance possibilities are. For example, not all computations have externally observable side effects, so those parts could be executed conventionally if the runtime could guarantee it. Or the program-visible clock APIs might be keeping virtual time that makes it seem from timing POV that operations are slower than they are, combined with network API checkpoints that halt execution until virtual time catches up with real time. Etc. Seems like an interesting research area.
Not all computations have externally observable side effects. You can time any computation, so they all have that side effect. Also, from JavaScript you can execute tons of C code, e.g. via DOM manipulation. There's no way all of that native code can be guaranteed to run with consistent timing across platforms.
Depends on who you mean by you. In context of fingerprinting resistance, the timing would have to be done by code in certain limited ways, using browser APIs or side channels that transmit information outside the JS runtime. Computations that call into native APIs can be put in the has observable side effects category, but in more fine-grained treatment, some could have more specific handling.
You only get fingerprinting from your method if the variation of the fingerprint between two different runs by the same user is lower than the difference you get between two different users. This is far from obvious, since it depends a lot on the workload running on the machine at the time. I'm not aware of a single fingerprinting tool that primarily use this king of timing attack, rather than more traditional fingerprinting methods.
Someone mean would say that this is not a bug, but a feature for the people who are paying for Chrome.
Google are the people paying for Chrome. They do not benefit in any way from this kind of fingerprinting. To the contrary, it decreases the value of their browser monopoly.
Google are the people paying for Chrome. They do not benefit in any way from this kind of fingerprinting. The largest ad company in the world, 80% of whose money comes from online advertising, does not benefit from tracking.
Even supposing that Google do benefit from it in that manner, there would be far simpler ways for them to make fingerprinting easier. It's extremely unlikely that this is a significant motivation for adding WebGPU. Not to mention that a lot of the fingerprinting you can potentially do with WebGPU can already be done with Webble.
All the operations are specified to deterministically produce the same but exact results on all hardware. I want this so badly. A compiler flag, perhaps, that enables running the same program with the exact output bit for bit on any platform, perhaps by doing the same thing as a reference platform. Any will do, even if it has a performance penalty.
This is huge news. WebGPU solves the incentives problem, where all actors tries to lock you into their graphics compute ecosystem by abstracting over them. It's already the best way to code cross-platform graphics outside the browser. This release in Chrome ought to bring lots more developer mindshare to it, which is an awesome thing.
WebGPU solves the incentives problem, where all actors tries to lock you in. Or flipped around, it creates an incentive problem, where none of the vendors see much benefit in doing R&D anymore, because browsers aren't content to merely abstract irrelevant differences. They also refuse to support vendor extensions, except for their own. No point in adding a cool new feature to the GPU if Chrome Safari insists on blocking it until your competitors all have it too. Luckily, the GPU industry is driven by video games and nowadays, AI, industries that don't write code using the web stack. So they'll be all right. Still, that same incentives problem exists in other areas of computing that sit underneath the browser. CPUs, hardware extensions, operating systems, file systems, etc. Abstractions don't have to erase all the differences in what they abstract, but people who create them often do so anyway.
There are lots of ways to write code cross-platform graphics outside the browser. It has been available for decades. It is called middleware. WebGPU outside of the browser not only suffers the pain of being yet another incompatible shading language, it also offers the additional possibility of having code incompatible with browsers' WebGPU support, due to the use of extensions not available on the browsers.
As far as I know, the WebGPU implementations outside the browser can all load SPIRV directly. No need to translate to WGSL first.
Yes, and that is one of the reasons why I wrote it. It also offers the additional possibility of having code incompatible with browsers' WebGPU support.
Or it will be yet another standard.
Not really. I don't see how any of the vendors could break it without being extremely overt about it. And it has no direct competition. Nothing else runs on any OS and any GPU, except Webble, which is abandoned.
Don't get me wrong, this is supremely cool. But I wish the W3C and browsers solved more real-world problems. Just think how many JSKBs and CPU cycles would be saved globally if browsers could do data binding and mutate the DOM, e.g., Morptum, DEM, etc., natively, and the emissions that come with it. Edit. For example, just consider how many billions of users are downloading and executing JS implementations of a VDOM every single day.
Can this be used to mine cryptocoins by malicious actors?
I doubt there's as much effort being put into crypto these days. The folks hustling on crypto are now in the AI space.
The browser truly is the new OS, for better or for worse.
Soon there will be no need to install softwares to the computer. A modern browser will cover it all. What scares me is browsers getting bloated with all kinds of features, while web apps getting bigger and bigger in size for no reason. Note, I am all for this feature getting widely adopted.
Chrome and Firefox have supported WebGL since 2011, and WebAssembly since 2017. What is the reason we don't have early 2010s quality AA game experiences running in the browser?
I lost all hope for WebGPU after they decided to roll their own ad hoc shader language that kinda looks like, but is totally not Rust. At least with WebGL you had C. Without SPIR5 support, this spec is just another tire on the fire that is the modern web.
Ad hoc shader language that kinda looks like, but is totally not Rust. But is that language actually bad? Or is it just not your favorite language? What don't you like about it? Get ready to rewrite all your shaders in WGSL.
Chrome will ship WebGPU in the next update. Current is 112, WebGPU is 113. Seriously Google, can't you just wait until you actually ship the stuff before you say you shipped it?